Hey, hello there, and welcome back for more Advent of Code. So, I have to confess, I've been falling way behind in Advent of Code. It is the 16th of December, and I just completed 4 of the challenges. So, yeah, I've fallen way behind. Last weekend I was pretty busy, but that's not a good excuse. You could say that I have been slacking off for the last few days, so let's try to jump back into it. So yeah, this is where I left off in day 5. Let's serve some mate and read what day 5 is about. So day 5, supply stacks. That's probably a clue about what data structures we are going to be using, or at least abstract data structures, I guess. I don't know what a stack is. So the expedition can depart as soon as the final supplies have been unloaded from the ships. Supplies are stored in stacks of marked crates. Crates. That's a funny word to use for a Rust project. In a Rust project, I mean. Okay, supplies are marked in stacks of marked crates, but because the needed supplies are buried under many other crates, the crates need to be rearranged. Okay. The ship has a giant cargo crane, nice name, capable of moving crates between stacks. To ensure none of the crates get crushed or fall over, the crane operator will rearrange them in a series of carefully planned steps. After the crates are rearranged, the desired crates will be at the top of each stack. Okay, so you have stacks of crates and you can move them with a giant crane. Oh, cargo is another it's another nice word for a Rust project. The elves don't want to interrupt the crane operator during this delicate procedure, but they forgot to ask her which crate will end up where, and they want to be ready to unload them as soon as possible so they can embark. They do, however, have a drawing of the starting stack of crates and the rearrangement procedure, your puzzle input, for example. Okay, so this is an example input. Okay, this is kind of an ASCII drawing of the crates, I guess, and then how the crane will move the crates around. So in this example, there are 3 stacks of crates. Stack 1 contains 2 crates. Okay, Z is on the bottom and the crate N is on the top. Stack 2 contains 3 crates. From bottom to top, they are MCD. Okay, finally, stack 3 contains a single crate B. Good. Then the rearrangement procedure is given. In each step of the procedure, a quantity of crates is moved from one stack to a different stack. In the first step of the above rearrangement procedure, 1 crate is moved from stack 2 to stack 1, resulting in this configuration. Okay, so crate D is moved from 2 to 1. Fine. In the second step, 3 crates are moved from. Okay, so that was this first step. Then move 3 from 1 to 3. So it's gonna be move this 3 from here to here. From stack 1 to stack 3, crates are moved one at a time. Oh, okay. So the first crate to be moved, D, okay, the top one, ends up below the second and third crates. Below the second and third crates. Okay, yeah, it's D and Z from top to bottom, and then it ends up Z and D here in the third. Okay, fine. So it's very stacky operations, like you only need to push and pop from the top of these things. Good. Then both crates are moved from stack 2 to stack 1, and again, because crates are moved one at a time, crate C ends up below crate M. Good. Finally, 1 crate is moved from stack 1 to stack 2. Fine. The elves just need to know which crate will end up on top of each stack. In this example, the top crates are C in stack 1, M in stack 2, and Z in stack 3. C, M, Z, okay. So you should combine this together and give the elves the message CMZ, okay. After the rearrangement procedure completes, what crate ends up on the top of each stack? Okay, and we have the inputs. Oh, okay, there are many stacks. So now the answer is a string of crate letters. So our previous assumption of every answer being 2 or a number is now invalidated. Nice. And by the way, man, this these inputs will need a lot of parsing to do this. Why did they give us the input in this shape? That they could have given like the initial configuration like in each line, like first line being the first stack and like have D, LV and only one line. But instead we have to parse vertical lines. Nice. And then we have the instructions. The instructions are pretty straightforward, I think, to parse. So okay, this will be a lot of parsing, I think, and then some stack operations. So let's jump into the project. Cd projects, Advent of code. Not that year, it's this year. Oh, I have some. I think I made some local changes. I guess they are to be pushed. What? Do I need to log in to? Oh man, I don't want to authenticate to this. Why do I need to log in? Isn't this... Wait, let me just open up the code editor and see. Sync up changes. Do you know how to do this automatically? Okay, blah blah. No, okay. Let's close this. Let's do it. Git push force. GitHub wants to sign it. Okay, yes, go ahead, sign in. I don't know why I lost my credentials there, but it got pushed. Nice. So let's create a new a new input file. Actually, I have been copy pasting the input files, and I think it would be better to save the input files in a better way. So let's go to Advent and what? Oh, this is just looking in here. Advent. Why don't you like this? Let's go to projects, Advent of code 2022, and inputs, and then you're going to be called day 5. Okay. So day 5 is saved, and let's create a new source file. New file, day 5 rs. Let's close other stuff. So we're going to need to refactor this this assumption of returning numbers from each day, but we can work around that for the moment. So let's import day 5 and let's add it here. So this will be day 5 run, which doesn't exist, of course. So let's do pub run. No, pub fn run, and this will take. What did it take? An input of type string slice, I guess, and it returns. Well, let's make it return what we were returning before, just a tuple of things, and just return 0, 0 for now, so it can run cargo run. It's funny that we're running this with cargo, and we are going to be running a simulation of a cargo crane. So okay, boilerplate is done. So what do we need to do this? First, we're going to need to parse these inputs, and it's not going to be easy, I think. Actually, I can, I guess, start with a sample input and see what happens. So day 5, paste and save, but not actually. Let's save without formatting. That's it. And what do we need to do? First, I guess we need to well, reload day 5 so the editor knows the tab size. We can split this input in 2 parts, right? We can first parse this and then parse the moves. Like, this is the initial configuration. And let's see. I don't want to make a like full fleshed out parser for this. Maybe we can get away. Yeah, I think we can get away by cheesing the parsing a little bit. Like, all the crates are single letters, so we can probably parse all of this first stack as like parsing the second character of each line. And actually this line where with the stack names or numbers is not really needed for parsing. We can ignore that. And since there are only 9 stacks, we don't need to worry about like 2-digit numbers, I think, you know, or any like weird formatting here in this. Like, everything is nicely aligned here, so I think we can take advantage of that. I think. Yeah, maybe we can assume some limits on how many, because like the real input is 9 stacks, so we know that we are not going to have more than 9. Maybe we can use like a static fixed size array for this kind of things. So how do we model? Let's see. Let's start with something like, we're gonna get the input and split once by double new line. So that will get us the 2 different sections of this. So we can call this 2 things. The initial, then I cannot see too well from the distance. Initial state section and the instructions section. Where are they called instructions though? Procedure, rearrangement procedure it's called. So let's say procedure section. So we are going to expect this thing. Input should have 2 sections separated by double new lines, right? So let's make sure that we are doing things fine, and let's print the initial state section and not do that. Yeah, okay. We are getting just this here. So let's say let the initial, no, not initial state, let's call it stacks. Let's stacks be just parse stacks. And pass this. Then can you help me out? Yes, thank you. Here we are going to parse this. We can call this input again, I guess. And what are the stacks going to be? Actually, does Rust have some stack built in? I guess we can just use a vector, right? Yeah. Yeah, we have pop back and push back. That's nice. That's nice. We can use a vector for these things. So the stacks, what are they going to be? I guess they could be. Can we use a static array? I guess we can. Static array of vectors of what? Of char maybe? And of size 9. That's not the syntax I want. This is the syntax I want. Nice. I guess we could extract this into a constant, but I think I'm going to be doing a lot of assumptions about maximum sizes and things like that, so I don't mind having them sprinkled all around the code, for now at least. Right. So, what do we do about this? How are we going to parse these things? I guess we could start by saying the results, or stacks, I guess. We can make this thing. Can we just initialize a vector here and have an empty vector 9 times, maybe? And then just return the result. What are you complaining about? Same syntax. What are you complaining about? Okay, the trait copy is not implemented for vector of that. But can't you be moved? What am I missing here? We can make a vector or the result, I guess. No, stacks is the result. Okay, and then what's the error? Can we tell this what's your type explicitly? So you want to copy these things. Ah, yeah, okay, because we have a vector and then it's going to be copied. Okay. Const val. We can make a const item or whatever. Can't we like declare this thing and let it initialize somehow? It's not initialized. Like, can you initialize? How do I start with an empty array of things or an empty vector? Rust initialize array of vex. Let's see. Oh, there's a default thing. Fine. And then the accepted answer is just copy pasting stuff. Okay. Let's do then defaults. Defaults and default. Do you like this? Yes, you liked it. And can you even infer this? Yes, you can. Awesome. Okay, so we have the stacks. How do we parse them? I guess we can do a for loop from I in going from 1. No, let's start with, let's do 0, 9. 0 based indexed as grown-up boys. And how do we parse? Actually, let's start by parsing only the first stack and see if we can do it. So the first stack is going to be like the characters on the second character of each of these lines. So we are going to do. We need the input split into lines first. That's our first step. So lines is going to be a vector of something, and input. Yeah, because we are going to iterate lines again and again to parse this thing, so it's nice to have them as lines. We're gonna get lines, yes, and collect. And these are lines, a vector of strings, I guess. Yeah. And we cannot access actually strings by direct index, so I guess we can map this into bytes, and this is now going to be a vector of bytes. Nice. So okay, the first stack, how do we parse this? Let's say stacks 0 is gonna be lines map. What are we going to map? Each line, well, I guess here each line is going to be an array of bytes, right? So we have we are mapping there, and we are just going to get the second character, I guess, and then collect. I'm missing a lot of stuff here. I think first of all I cannot map directly. I have to use an iterator. Fine. What don't you like? Oh, you cannot index into a type of bytes. I thought. Is it as bytes? Yes, it's as bytes. Yes. Good. And then, oh, this is inferring something different, I think. What's the problem? Type must be known at that point. Can we say something like as char? Okay, it doesn't like the stacks, so let's put this, and now it's complaining about cannot assign. Oh, it's because it's not mutable. Of course, it should be mutable. Okay, we do have stacks. Can we now debug print this? Println, and we are going to, I think this is a debug print of stacks. Darn it. Okay, I was missing something still. This is this looks like the first stack, although we should be discarding, of course, the empty, like the space here and the number from here. Actually, we could go. We could grab a slice of this. Actually, this we are collecting here. We could just say something like, let's call this all lines, and then have stack or these are the I mean, we can drop the last one. So how can we avoid that? Well, let's say lines and have all lines minus the last one. All lines len minus 1. And you don't like what's. Yes, you don't know the size of this, but why do you care? But can't you be just why is this complaining? Like, you can totally be a slice, right? Is this what you want? Can you get a reference to this? Okay. It likes that. Do you need this, the static type? No. All right. So now we should be ignoring the last one, I think. Let's run again. Yes, we don't have the number. And I guess we can also, here we are mapping to the characters, and then we can filter. There was a filter map there. What is filter map? What is this thing? Oh, my face is on the way. Darn it. How do I move my face around? Sorry for this. I want to see the documentation. Okay, it maps to an optional thing. I guess we don't need to optimize this into one operation or anything like that. Let's just use normal filter, and we are going to have what's a character, and we want to filter the characters that are not the space character, different than space, I guess, and then we can collect. Yes, let's borrow that character. And how about now? Yay, so we have the first stack of the example. So it's ZN, right? No, NZ. Why? Oh, because we are going from top to bottom. We should reverse this, right? Because we want the top thing to be the N. So we are going to do we can, I guess, reverse this thing. Ref. How about now? Yes. And I guess if we are reversing the iterator, we could probably get rid of this and just do lines iter reverse, drop the first one. Isn't there a drop? No. Skip or something like that? Yes. What is skip? Elements are skipped to the end. Perfect. Does this do the same? Zn. Yes, indeed. Okay, so now we are parsing one stack. We should, however, parse everything. So how do we do that? We can make a for loop, but I'm kind of thinking ahead of myself. But let's make this thing into a loop. So for I in 0 to 9, let's do same thing, but we are going to create the stack number I. So how do we do this? What changes is how do we index this thing. So I guess we can say let's index, yeah, the how is the index? So let's see, the first one was index 1 because it's like not 0. So then we have like 4 characters plus 1, and then here we have the other characters. So I guess we can do something like the index shall be I times 4 plus 1, I think. And here we index by this index. Not the best naming to have I and index. How do we call this? Char index. Yes. Okay, let's see if it works. We panicked. Oh yes, because we in this example we're going out of bounds. We are going up to 9, but this example is smaller than 9. So we can actually do a bounds check here. So if the char index is greater than lines 0 length, greater or equal, I guess. So if it is out of bounds, we are gonna simply break out of this loop. And let's see if this very procedural code works. So it looks to have worked. So can we see the inputs? MCD, nice, and P. And then the other stacks are empty, but I don't care about empty stacks for this sample input, because then the real inputs, they won't be empty. And actually, let's try this with the real input and see how it does. Okay, they are longer, but let's see the last one, I guess. Homepage. Oof, there are many instructions. So it's RDL up to T. RDL up to T. Nice. So it seems to be parsing the stacks all right. That wasn't too bad. This is parse stacks. Yeah, this is a bit hackish, some of these things, but I think it's fine. Do you need to know the size here? It seems it does. Not allowed here. Okay. Oh, I thought that was able to infer this kind of thing, but I don't remember how this works. Actually, can you like know this? No, you need to know it beforehand. Okay, like this is the result. Okay, we can probably put a name to this and call it a stack, right? Type alias. Let's say this is a stack, and here we have our results. Is this good? I don't know. Okay, but we have the stacks, and we are probably going to mutate them. So let's make them mutable, and I guess we can just go through the procedure section. Yeah, and just go applying each of the operations and see if we get this. So let's do procedure section lines. I guess we could parse this also and have like rearrangement procedure or something like that be a parsed thing, but well, let's leave that for part 2 if we need it. So we're going to iterate over this. So for line in this thing, let's do, what do we need to do? We need to parse this line, I guess. So we're going to, let's go to the sample. Darn it, don't I have the sample? Copy, paste, save without formatting. Do you still like this? Yes, you do. So the procedure part says move 1 from 2 to 1. So we have the amount to be moved, the initial or like source and destination, we could say. And these amounts, I think, yeah, some of the amounts are 2-digit numbers, so we cannot do the same cheesy solution to parsing of like accessing these numbers directly from the input bytes. So let's say something like let's amount from and to be parse. We can call these things moves, right? Parse move from this line, and we're gonna generate this function. Let's move it to the bottom. How do we parse a move? So this thing is going to return a tuple, I guess. I guess we could also put a name to this and make it a struct that says amount from and to, but we shall see. If we keep reusing this, maybe it would be good to give it a name for, but for now, let's have it like this. So how do we parse a move? I guess we can split this by a single character, like split it by spaces, and just grab the second, fourth, and sixth words from that, and then parse them as numbers. I think that could work. Yeah, let's say that. Let's words be a vector of things and collect this. And now, what do we need? Say let's amount the words 1 parse. We are going to have amount from and to, and this is going to be the second, the fourth, the sixth array. Zero-based indexing messes up with my head. And let's return amount from and to. Not you, not yo, to. So it doesn't like this because, oh, it's a result. We need to expect these things. Let's use multi-cursor. Expected invalid number. Okay, this is a bit repetitive, I guess. We could, I guess, make this thing return. Like another alternative to doing this would be to say, use this, and let's see if Rust suggests no. This would be returning a result. No, but let's just do an expectation for now. We can improve the parsing rate. And let's see what we parsed. Println. Moving amount from, like this is almost the same line that we actually, can we interpolate here? Amount. Yes, it seems like we can interpolate from and 2. Run. Yes, look at that. It does seem like the input, right? Yeah, cool. So now all that remains is to make the moves, actually. So we're going to be modifying these stacks. Let's actually close this sidebar. Okay, how do we make the moves? I guess we could do something like this amount of times we need to do something. So for we don't even need to put a name here, right? For in amount, let's do. So we're going to have this from and to. Oh, actually, we're going to be indexing into the stacks. So I think this should be U32. They should probably be usize. Yes. So stacks from, we're going to pop. Actually, wasn't it called like pop back? Or am I tripping? Well, let's see. What does pop do? Last element from a vector returns it or none if it's empty. So it shouldn't be empty. So let's call this let's crate this. Oh, the variable name crate doesn't like it. Yeah, it seems it's a reserved word, so we call it what? Top crate. So we pop it. We expect it actually. There should be a crate in here. Stack should have a crate, and so the top crate should be a char. Yes. And now we should pop it into the other one. So stacks 2, we're going to push, I guess. Yeah. Yeah, I think that should be it, I think. So if we then print the top of every stack, I think we should be fine. Let's do for what's stack in stacks. We are consuming the stacks here, but that is fine. Print the what stack peak or top or what last. Not liking this, so can we actually do something? I don't know if the printing works like that. What? Not should I? Or none if it's empty. So I guess, yeah, we need to. Let's unwrap it for now and see if the result is what we expect. It panicked. Why did you panic? Variable to display. Oh, stack should have a crate. So we are popping more than we need to. So if it says like move 1, we should be okay. Let's do something. Let's print actually println here and say moving mount from to. Oh, okay, this I already noticed an error here. So one of the mistakes is that we are indexing with one base indices, and the these stacks are zero base index. So we have to subtract one from here, I guess. Yes. Do you like it now? Oh, ZMZ. I think that is yes. This is the correct answer. So, oh man, does this work? So save without formatting. Let's go to the top. We are not removing any, well, I don't know if we are removing spaces, but I think it should be fine. Let's run. Okay, this is, oh, I'm printing the zero. The zeros should not be included. Is this the correct answer? Yes. Nice, that was the correct answer. So part 2, I'm not like super happy with this code, but we can probably improve it after we see what part 2 is about. So part 2, as you watch the crane operator expertly rearrange the crates, you notice the process isn't following your prediction. Some mud was covering the writing on the side of the crane, and you quickly wipe it away. The crane isn't a crate mover 9000, it's a crate mover 9001. Wow, over 9000. That's a subtle reference. The crate mover 9001 is notable for many new and exciting features: air conditioning, leather seats, and extra cup holder. Nice. And the ability to pick up and move multiple crates at once. Oh, okay. So again, considering the example above, the crates begin in the same configuration, this, but then moving a single crate from stack 2 to 1 behaves the same as before. Okay, from stack 2 to 1, D to here, fine. However, the action of moving 3 crates from stack 1 to stack 3 means that the 3 moved crates stay in the same order. Okay, resulting in this new configuration. So we need to move the things in the same order. Next, as both crates are moved from stack 2 to stack 1, they retain the order as well. Okay, finally, the single crate is still moved from stack 1 to 2. But now it's crate C that gets moved. Okay. So then it becomes MCD. Multiple common divisor, and before it was, no, okay, yeah, it was not a reference to something else. Before the rearrangement procedure finishes, update your simulation so that the elves know where they should stand to be ready to unload the final supplies. After the rearrangement procedure completes, what crate ends up on the top of each stack? Okay, so we have to reinterpret what we did. Nice. I guess here we can println. Actually, is this the correct one? Yes, let's println here. I'm a bit slow today, but let's actually recreate the stacks with initial configuration, so we forget what we did, and actually let's copy all the code, and then we can remove the duplication. So we're going to do basically the same thing. So if we do the same thing twice, we're gonna get the same result twice. No surprise there. I just wanted to test that we are starting with, we are parsing the stacks again. So how do we move things now? Basically, we cannot do popping and pushing. We have to like move everything at once. So I guess we can still pop into the destination, or I guess push into the destination, but we cannot pop from here. We should like read from an index. So let's use an index variable I here and grab. This is not going to be the top crate. This is going to be just a crate that we're going to copy, and then we can like clean the initial stack. So where should we index? We should take it from the, I guess this is, we can call this thing the the source stack. We can put it here. Yes. And the source stack, we can index it at we're going to go from, oh man, I have to think. The length minus the amount, I guess, plus I. Is this correct? This is not going to be the top crate. This is going to be just a crate, I guess. And this doesn't like it. Oh, you're moving. Let's not do that. Let's take a reference to this. Oh, and this is a mutable reference. Yeah. Let's do something like destination stack. This is going to be 2. And can you both be mutable? Can you please? How about that? You don't like this as mutable? But you should be mutable. Does not need to be mutable, but I want you to be mutable. Can you be a mute reference? Or like this? This is not the syntax you want, right? Reference to vector. We can take it mute from here. Okay, now I think it's going to complain that you cannot borrow stacks like that. Yeah, nice. Why do I want to separate this into variables? I don't know. Let's actually remove all of this, not so much. Let's just do this and this, and then we can see how to improve this. But if we run now, Q. I think, I did something, but probably not the right thing. Let's use the sample inputs, and let's we have to clear up the from stack. So let's grab this, this thing. Can we splice? Yes. It's gonna get a range or remove. I don't know. Well, splice from what? From the length minus amount. I'm probably missing doing a lot of off-by-one errors here. Yeah, now from here to indefinite. Now this should be len. Yes, and you're missing a second argument. So I don't want to replace it with anything. Can we do something like Rust remove last n elements from back? I don't know the APIs of X. Yeah, here's doing a lot of popping. What? Truncate. Yes, truncate. That's what I want. Yes, truncate. So if the amount was 1, yes, if the amount was 1, this makes sense. Like you are subtracting 1 from the length. That seems fine. Let's see. Non-value. So, okay, it got bad here. We're using the sample input, so I guess we can print the stacks as they go. So here we are println moving amount from to 2. Good. And let's also debug print the result after this. So println debug the stacks. You don't like this, of course. This is kind of broken. How about now? Okay. What? Oh, it's failing this one? What? But this is the first. What did I mess up? What did I mess up? Like it's printing the first. CM said, oh, we there are more stacks. Yes. So actually, we don't want to unwrap here. We want to. Let's uncomment this. So that was silly. It was exploding like from the first. From our first attempt, because when we get to, yes, this is the sample input, we get to the fourth stack that doesn't have a crate on the top, it fails. So can we, instead of saying last here, I guess we can say let's last or top crate be stack last, and if it is sum, then fine, else break. And here we can print the top crate. Do you like this break? I mean, it's weird that you like it. Or am I missing something? Okay, CNZ and MCD. That was the correct thing, right? MCD, nice. Okay, let's copy this ugly code for printing the stacks. So we don't have a. Did we have panic? I think yes, we did have a panic. And now MCD, and we don't need to print this. Let's keep it though, in case we mess up with the real inputs. Let's go to the real inputs, save, and rerun. Okay, we have some answer. Let's try it out. Yes, golden star. Nice. I think I haven't gotten a wrong answer yet, like when trying to submit. That's very, very nice. So look at that. We have more of the drawing, and we have actually 10 stars. That's very nice. And we have an answer for this. Let's clean the code a little bit. If I remember how to... Man, I'm not remembering any of my shortcuts. Is it Ctrl Shift K? Yes, Ctrl Shift K. Okay, there are lots of nasty things here. So, where should we start cleaning? I guess there is no problem with reparsing the stacks again, although we could be making copies. But let's leave that for now. Parsing the moves again is maybe a bit wasteful, I guess. We could have like there's some repetition here, but yeah, I think I am okay with that repetition. And what about this? This is a bit nasty, all the -1s here, and truncation. Can we do this any better? So truncate, I will guess, doesn't return anything, right? No. Oh, you can use the drain method to emulate truncate, but cause the excess elements to be returned instead of dropped. Okay. Okay, that's cool. If we run this, let's keep that output. I guess we can use drain. Let's see. If we drain this, it gets a range, removes the specified range from the vector in bulk, returning all removed elements as an iterator. Okay. So the returned iterator keeps a mutable borrow on the vector. I think that will cause us some pain with the borrow checker here. Because we could, I guess, like this is the source stack. We can get everything and put it on the destination stack, but if we do that, like for let's say character in this iterator, we can push it into here. Push character, but it's going to complain. Okay, also you need a range, so you're going to start from there, yeah, and go till the end. But now I think we're gonna have some borrowing things. Cannot borrow stacks as mutable more than once at a time. Second mutable borrow occurs here. Okay. Yes. Can we it would be nice to borrow like two mutable two stacks, like the source and the destination, as mutable at the same time, because like if we know that they are different, we should be able to mutable borrow them, right? If we know that from and to are different, but they could be the same. Like that's why that's why Rust is not being happy at us for this. Or I guess we could drain and collect this iterator, and yes, just do that probably. So let's extract this into a variable. Let's call this crates, and we are going to we're going to collect them into a little vector. And is this better? Actually, before doing all of this, let's go back to the truncates, to here, save, and let's add everything so that we can see what changes we make to improve this. So let's repeat all of this. And we don't need this for, I guess. We're going to drain from here and put it in there. And I guess there's probably a method for doing this. So instead of push, can we append? Yes. Moves all the elements from other into self. So append crates. What don't you like about this? Okay, let's make it mutable. And pass it as mutable there. Does this work? I don't know my answer. MCT. Yes, MCT. So this also works. I guess we are doing it in a more streamlined way. It would be nice to be able to drain and not having to make an allocation for, like not having to collect this thing. Can we actually do something like that? So Rust get to mutable borrows from array. Elements slice. I think I might be over-optimizing this thing, but I mean, I do like to do that sort of things. Let's see actually this change. So okay, the code at least is a bit more, it has a bit less direct accessing of things. But it would be nice to be able to grab mutable borrows of two of these elements from array. I mean, this is from a vector, but I guess should be similar. Slice much. Okay, so I have no idea what I'm reading about there. Let's see, do I like this better than before? I sort of do. Yeah, I guess so. So here we have, we're draining the from stack, and then we are appending all of that into the destination stack, or the to stack. Amount from and to. Okay, let's add this change. What else can we do? One thing that I would like to do, I think, yeah, this moves. Let's first try change these moves to 0 indexed, to be 0 indexed. So like from and to are actual indexes into the stacks arrays. So we don't need to do -1 all over the place. So actually, let's remove all of these -1. That should be better, and I think should be, well, no, you didn't like it. Why don't you? Oh, you need a type annotation needed. Well, I guess size. Are you okay with that, or do you need it in the parse? Actually, we can do the -1 here, and that's it. -1 and -1. No, actually, you want, yes, you want an explicit type. Okay. Good. Okay. Yes, that was the same. Good. We could also. Okay, let's go step by step. First of all, am I okay with this solution? I think I sort of do. All in all, like, it reads more or less okay. We are now accessing stacks with direct indices, so that's better. We are we are maybe parsing the moves twice and parsing the stack, the initial stack twice. That's questionable, I guess, but we can live with that. And then we have this, which I don't really like. We could improve this. Yeah. And of course we are printing the answers and then 0 and 0 because we are assuming these numeric answers. But I mean, other than that, I think it's an okay solution. Like, it's at least it's the correct answer. So let's see, the parsing of the stacks. Yeah, we're doing bounce checking here and short-circuiting the return. Can we do something differently here? I guess the fixed size is making some things easier, I think. Yeah. I guess we could also like return a vector of stacks and not have like, yeah, maybe that's actually better. Let's try that out. So if parse stacks returns just a vector of stacks, so it's basically a vector of vectors of stack. We're gonna have stacks be a vector. Okay. Then we early return here. That's fine. And other than that, everything else keeps being the same. Oh no, not the same. Where's the error? Oh, now mutable borrow. Oh, we cannot. Okay, so arrays. The array was not the same as the vector. Why not, though? We are getting an immutable borrow from here. We're getting an immutable borrow from stack. I'm not sure what's your problem here. Like, let's maybe extract this into a variable. Initial or like this is first create index. Okay, I'm not sure why it was complaining, but we have an index out of bounds in line 45. What? Oh yes, okay. Yes. Right. Huh. So we should actually know how many stacks there are. We can probably know that from the input, right? We could, I guess, use the last line and see this number here. That's a possibility. Or can we? Actually, we can just push into here. Yes. This is gonna be. It's actually gonna be the stack. Let stack of type stack be this, and then stacks, just push it there or move it there. Are you happy with this? Yes. Okay. I guess this is fine. So we don't have like a fixed array, and now that we don't have a fixed array, we can actually here when printing, we don't need to consider like the last when there is nothing. So we can kind of unwrap here. Yes, and let's call this top crate. And see if it runs. Yes, it does. And actually, let's inline this variable. Don't you like inlining variables? Okay. Let's do this, and let's do this. And bye-bye. Okay. Actually, we should be expecting this. Stack should have at least one crate. Have a crate. Okay. Yes. I think this is fine. Yeah. We run, we have the same answer. Yes, we can remove some duplication later, but I think this is fine for an initial commit. Git commit. Day 5 solution. All right. So, what can we do better now? I guess we could do the parsing beforehand and then have, yes, not repeat the parsing of the moves. So I guess we could have something like let moves be parse moves and procedure section, or yeah, let's call it procedure moves. Yes. Get me this thing? No. Can we generate these parse moves? Yes. So we're going to just maybe delegate to this parse single move. Okay, but moves are now like a tuple, not so great. Let's make it a struct. So we're going to have an amount, a from and a to, all of which are going to be usize, and that's it. Parse move is going to give me a vec of moves, and this is going to be an input. Input, and then we're just going to do input lines map parse line, or parse move, I mean, and collect. Are you happy with this? No, because this doesn't return a move. It should return move then. And here we can say move with this amount, and from it's gonna be this, and to is gonna be this, and I don't remember the syntax for this. Okay. Yes, I'm more or less happy with this. It's a bit verbose to have declared the move type, but let's continue on and see if it's a good refactor or not. So here, instead of procedure section lines, we're going to go through each move in procedure moves. For move, you're going to have an amount, a from, and a to. And we can remove this parsing. And here, you can copy this and do the same thing here. And no need for another parse. Well, you don't like to have these procedure moves again because we are consuming it here. So let's do have the parsing first. Then we are going to actually the mutable stack should be here. Let's have an iterator for this and have what? This is a reference now, right? Yes. Can we take a borrow from this? Yeah, okay. Yes. So we are iterating these moves. We don't have to consume them. And yeah, that seems fine. Let's see the changes. I mean, this surely makes the code longer, yeah. But we have given a name to the moves, and we have also, yeah, we don't need to do the parsing again for each line. Do I like this? I think I do. I think I do. Maybe we can inline this thing. Don't you like this? Why can't you? No, you can't inline. You are not so smart. Maybe we can inline it like this. Yeah, this. Actually, I think I prefer the previous code. Let's keep it as it was before, less noisy. Yes, we're going to parse a single move. And yeah, this is okay for parsing the moves. Also, the stacks, I guess we could do something like make this be like let initial stacks be this, and then have a mutable copy of this. Initial stacks clone. Do you like that? Yeah, I think you do. And then we can do this again and not parse the stacks twice. Is that any good? I guess the parsing is done only at the beginning, so all this code is about parsing, and then we have the two parts of the challenge separated here. Let's run and see that we get the same answer. Yes, we do. Okay, we are also consuming the stacks here when we are printing, which is fine by me. Yeah, okay. I'm good with this. We can take a look at the on how to do at least the printing better later, but let's also take a look at how we are parsing the stacks, if we can improve something. So here we are getting the lines as bytes. Fine. We are doing this very procedural thing, which am I fine with this? I think I am. Here actually we don't even need this 9. We can just start from 0 and break once we are out of the, once we are out of bounds. So does this still run? Yes. Yeah, I guess this is fine. Char index, fine. Just keeping the first line here. Am I fine with this? I guess if we are always skipping, I guess we can do the skip here. No, we would have to reverse and skip one here. But then we wouldn't need to reverse and skip things here, I think. We're only collecting the lines for the crates. Does this still do the same? Yes, it does. Good. Let's see. collect stacks in reverse order and ignore last line with stack names. Good. Then we have a stack, and we, yeah, this is pretty okay. We filter things that are not empty. Yes. And what do you think about inlining this variable? Doesn't make much of a difference, to be honest. Let's keep it like this. And then we return these stacks. Yes, this parsing is okay. And how about parsing the moves? Can we improve this somehow? Well, I guess we could split, and then, like, instead of getting a direct index into each of it. So okay, first, before anything else, let's add these changes, because I'm okay with those. And let's see. Another alternative could be to just keep everything that is a number. Yes, something like map each word into word parse usize. Let's say these are nums, and can we is there something like map no, not map while, flat map, filter map? I think flat map might be what we want here. So what are nums? It doesn't know. Can you declare the... No, I don't know if flat map is what we want, but I would like to say, okay, like, try to parse each word as a number, and if you cannot parse it, then skip it. So is that something like option? Why is flat map? Let's see. Rust pick of results, filter errors, or yeah. Filter map. Filter map, okay. That was what I wanted, I think. Is that what I want? Numbers? Yeah, this is kind of like the exact thing that I'm doing. This is ignore the failed items with filter map. Okay, so how does this work? We are doing a map here. Let's say a filter map. Filter map takes yes, I think that returns an option. So here the okay. Convert result to an option. I didn't know about this, but this is very useful. Okay, so if the parsing goes okay. we filter those out, and things that are not numbers, we don't care about them. That's pretty good. So now that we have the numbers, I guess we could say something like what? Let's if the amount, we actually don't even need to collect, or do we? I don't know. If the amount from n2 are these nums, let's splice everything, and else we are going to panic. Invalid line. Let's pass line. Actually, I don't know why I'm doing those error messages with passing arguments, if we can interpolate here. Okay, we have to declare here that this should be vector of usize. Let's say good. And do you need the parsing here? No, you can infer everything. Nice. Okay. We do this let, and that's it, right? Then we return the move. That's pretty good. It's actually quite nice. Yes. Does this still work? Yes, it does. So I think I do prefer this to what was there before. Well, it's a bit longer in lines, but we don't have this repetition of parsing and expecting things. And we can say something like, yeah, invalid line, just that's fine. If we don't have 3 numbers, it's an invalid line. And then we return a move. I'm still considering not having this move struct. Actually, we could probably make this, I don't know, how is it called, a tuples tuple struct, usize and usize, and we just name these things when we use them. So we just do something like this, I think. Do you like this? Why don't you keep this into a single line? I don't know if this is doing something like prettier does that. Oh yes, okay. I was getting annoyed by the verbosity, but I could collapse it myself. Let's see. Okay. No, actually, Rust really likes to split this into lines. Okay. Let's then try to make it a tuple thing. Yeah. You're gonna be a struct of this and this. And here the move is gonna be something like this. Yeah. You don't need the tags here. Okay. And now the moves, we can extract them with parentheses instead of curly braces, which is a huge difference. Yeah, not really. Okay, but this is a bit more succinct, and I think I like it. Does it still run? Yes, it does. So, yes, we are panicking here. That is fine. Or I guess, is there an abort or something? No, abort is not what I want. Panic is fine. Yeah, we are parsing stuff out. Here we are parsing each move. Good. And then we are using each move here. Very good. Okay, I think I'm more or less okay with this solution. The only thing that I'm not really sure I like is the drainage from here. Like using drain, maybe it was better to just use an index and copy from one and then push into the other one. But this is kind of the same, I guess. We can try that again and see if we can make it a bit clearer. But for now, let's put this. Okay. So yeah, maybe we can do something like this is the first create index. That's, I guess, a nice variable name. We can do something like for I in first create index 2 stacks from len stacks to push. Actually, we can just use a crate in stacks from going from first create index till the end. We can push a crate here, right? You don't like this. Cannot be known, blah blah. Oh, it's not an iterator. Can we take a reference? This is a reference to a car, so we can dereference this, I think. Yes. Remove this. And wait, what was this? The drain, yes. And we have to truncate the from. Stacks from truncate to the first what don't you like? First char index. No, actually the truncation is the new size that we want to have. Yeah, but it's the same thing. Don't you like this? Why not? What? In this scope? What scope index? Oh, crate index, not char. Oh, borrow checker. We have a mutable borrow here. once. We have an immutable borrow to this slice. Yes, of course. Of course, and you don't know if the from where it comes from. Yeah. Okay, let's actually keep the drain maybe. Yeah, discard these changes. Drain. Yeah. So this is the first crate that I guess this is the bottom crate that is going to be moved. We can say something like bottom crate index. Yes. We are going to, these are the moved crates, and yeah, a bit of better variable naming. That is okay. Top crate here is fine also. Yes. Yeah, okay. I'm fine with this amount of refactoring. I guess the only thing that remains left to do is to make this somehow return the two answers as strings instead of numbers. But for now, let's see the changes. So what did we do? We made the parsing only once. Then we also improved some variable names, and we sort of improved the parsing, I think. Actually, maybe the parsing of this was a bit a bit clearer, but I'm fine with this too. Yeah, because the other one was going to have like index out of bounds if it failed. Now it can tell you, hey, you have an invalid line. Yeah, let's commit this. Improve day 5 solution. Do parsing or parsing of initial crates and or initial stacks and moves only once, and improve and some other minor improvements. Yes. Okay. So I don't know if this video is probably already quite long, but I want to do something about this this thing of returning. Whoops. No, you don't like that. I'm not doing. I don't know what I'm typing. Cargo run. Okay, so day 5 is printing some garbage here. So I guess our assumption of all day solutions having like 2 numbers was indeed valid. I feel a bit lucky that it was only on day 5 that we discovered that. So I think the easiest change that we can make to make the solutions support like anything, like instead of changing this return type to be, I don't know, some kind of like result, which could be to like a tuple of numbers and a tuple of strings or things like that. I guess we could also make this like string and have the other days return those numbers converted into strings. But I think the easiest thing would be actually to just return a string and you know, have each day take care of formatting that strings as they want. If they want numbers, they can use numbers. If they want strings, like in this case, we can have strings, and that's fine. So we can call, yes, we can try that out. Let's see, let's start actually by day 1 and see how it goes. So instead of returning that, let's return a string. And now here we can do something like formats and have this, and actually we can like just put a space between these two. We don't need a new line, I guess. Do you like this? Yes, you do. So here I guess day 2 is something that doesn't like that. That is fine. We can go to day 2 and do the same thing. Yes, let's actually print this, or sorry, copy this. I mean. Day 2. We sorry. Yeah, we have total score 1 and total score 2. Do you like this? And no, you don't, because you need a string here. You don't like this because yes. What was the no total score 1? Oh, okay. So it was just total score. Very good variable naming. Yes, it was total score. Yes. Fine. Let's go to day 3. We can make this a string again. So this is a pretty mechanic refactor, I guess. We can have shared items, blah blah. I don't know. Yeah. Yes. Fine. Before, same thing as before. Make this a string. Make this, return format with this and this. Yeah. And yeah, they're just returning strings with the 2 answers concatenated. So here we just say output and print the output. Are you happy with this? No, because day 5 we still need to make this thing return a string. So here I think we have to put this thing into a string. So how do we do that? Maybe we can do sorry cats. Can we do something like stacks join? Yeah. Separator. Oh no, actually we need to stacks iter. Oops. Filter map. I guess vec last or stack last. and we have the last things, and then join. Does something like this work? So we can first try to just return an empty string here to see dummy into a string. And what about this? Let answer 1 be this thing, and just println the first answer. We don't have a join. So what's happening here? Would you be okay with saying like stack last? This is an optional, and then can't we like join this? Can you join it with like an empty string like this? Do you have a suggestion? No. Okay, let's say last iterator join. Oh, I guess this is, well, let's see. Iter tools I don't want to use. Actually, we could probably collect this into a string. Can't we? I say collect. Oh, okay. Answer 1 should be a string. Yes. Cargo run. And day 5 has that. I don't remember if this was the correct solution, but I'm assuming it is. The first solution answer was LHQ. Yes, LHQ. Okay, so this is one way of getting this. Now, aren't you happy with saying stack last here? No. But if you do vec last, or vec of char last, no, you really don't like that. What's the error though? It's not an iterator. Okay, I'm not really sure why you don't like that, but I'm okay with this. And let's say answer 2 is going to be similar to this. And then we can remove this, and we can format the answer 1 and answer 2. Yes, very good. And if we run all days, good, very good. So can we improve something? I guess we could extract this into some function or something. Let's yes, extract this as this and say top get top grade letters. Yes, we're gonna get stacks, and here it didn't recognize that we have a little how do you call this thing? Type alias for this. So this should be a vector of stack. And should we be moving? I think not. I think we could take maybe, or maybe we could take a slice and slice reference. Yes, and here I guess we can do get top blah blah stacks. There's an error here, but for some reason this underlining is a bit annoying. I think that makes it go away. So let's take a reference. Nice. So those are the two answers. Part 1 answer, and wasn't I thought I was renaming. Part 1 answer. Oh, but the rename is not affecting this. That's quite bad. Part 2 answer. It seems like the editor doesn't know about these macros. Well, that's too bad. But yeah, this is quite good. I guess we could make the day something be on the same line. Let's see. This is run single day. And here we are printing this. We could, I guess, do single prints like this. Yeah. And actually, if we run like day 5, it wouldn't be bad if the day 5 gets printed. So I guess we could do this over here. Run single day, print this, and then well, I guess we can move it here. Yes. Yeah. From now, we have day 5, and that's okay. Here we are running the output. I guess we can even do a single print, have the output and just do this. Println they num be that output. How about that? Yes. That's very good. Yeah. So what we did is we changed all the outputs to be strings instead of a tuple of 2 numbers. So I guess for all days this is quite good. For day 5 that we did just now, it is a bit messy. Let's move this function that we extracted to the bottom. So yeah, and we don't need to declare the type of this. It can be inferred. Yes. I think I'm good with this. Let's commit. Let's actually commit everything. Okay, let's say change daily solutions or day solutions functions to return a free-form string instead of a tuple. Yes, this gives day solutions total flexibility on the shape of their answers without complicating the return types too much. And nice, let's commit and let's push. All right, so I think that's it for today. I need to get going. It took quite a while to get to a solution of for this day, or at least it took a lot of refactoring, but I'm pretty happy with the solution thus far, and I'm pretty eager to get to day 6 soon. But till then, see you later. Bye bye.